welcome to MySec Lansing.
Yeah!
For announcements, I think the only one is B-Sides is less than a month out.
Road to B-Sides, get ready, get your tickets.
Yes.
Expect info. If you're a speaker, there'll be info coming out either tonight or tomorrow. If you're a volunteer, you should have something by the end of the week as well. That'll include what the schedule looks like and more info for you.
Do the F8 thing again?
I'm doing the F8 thing. It's not doing anything.
Thought we'd do that.
Any other interesting or announcements?
Anyone in the room have anything interesting? Things going on? Topics for discussion?
They've all been hashed down.
And one moment we'll work on some video issues. Boom.
Alrighty.
Here we go.
With that, I'll hand it over to Mark.
Alright, we're gonna see a quick blip on the screen here as we do something.
Staring on my table, that's nice.
Mm-hmm.
What do they all say? Yeah. Missed servers.
You're missing some servers?
I missed them, I'm so sorry. It's up there. You just gotta,
Yeah, it's up there and I can't move the terminal over.
because it was F11'd.
Why would you do that?
It's a tiny screen. There you go.
And this is gonna work out for a second.
Okay. Alrighty.
All right.
Is that working, Kyle?
Alright, we'll just go ahead and go. I'll work on
Okay.
this while you do that.
Okay. This will be fun typing over there because I can't actually mirror the screen. All right. All right. We're just gonna chalk because chalk works.
Yeah.
Chalk doesn't argue with me. All right. So you've probably heard the idiom that in Unix or Linux that everything is a file. Because everything is a file, you can use that to redirect output to basically a different file descriptor, and some applications or some instances, a application will output different output to different streams, and you can capture those different streams with different input-output redirection. So there's this is standard in, there's one, which is standard out, and there's two, which is standard error. And now, if you've got like, the typical situation that I see this in is if you've got like a cron job that's running, anytime that cron job generates output in whatever it's doing, it generates an error, it generates a logged output or anything like that, it's going to, the cron system is going to generate an email which sends to the mail to address inside of that user's cron tab. So what you can do to take any errors or any output is you can redirect that to silence that cron job. You can take that output and you can redirect it to something like dev null, the never never land of the Linux Unix world. So you can say, I want to capture so say you want to capture normal output and you want to send that to a file. You'd say output outwaka to file. If you want to capture errors, which are actually a separate stream, you'd say to out to file. This is errors. And if you want to capture both, you can combine them. You can say to out and one file. And this actually tells you to direct standard error to standard out and then direct the whole thing out to a file. You can also do and out, which is equivalent to this notation, just simpler to write. Now this, the single waka, will overwrite. It will create a file if it doesn't exist, and it will overwrite or truncate a file that if it does exist. So this is overwrite. But there's also an append output. So you can say out waka waka, which is append. And so if you've got multiple things in your script or your command that you want to output to the same file, you can create the file and then continue to add things to the end of it, as opposed to overwriting it with the single out waka. All right, now you don't ever really write this as one out. This is just a notation to say this particular stream. And the input, you also never really write it with the 0. It's just, these are the standard names for those file descriptors. So, you don't always redirect to a file. Sometimes you redirect to another application. You've got one application that's generating output that feeds into the next application. You're using each Unix utility like a filter. And it's filtering and changing the stream of data as you go along through what we call a pipeline. So you've probably heard of something called a pipe before. Just a vertical bar, it's shift backslash, so we've got pipe. This is a pipe. And what you end up with is standard out on one side, going into standard in on the other side. So command 1 feeds into command 2. So we've got the concept of standard out, standard in, standard error, outputting to files and outputting to a pipe. But the pipe isn't the only way to combine two commands. This is if you need them to feed off of the same data stream. If you want to just combine a sequence of commands that are just purely sequential, you can use some other tools. Everybody pretty cool on this one? All right. If you've ever parsed through a giant list of files and somewhere along the way one of those files either gets deleted because it's perhaps like an email message in a mail queue, it's delivered so it disappears. If your particular utility that's trying to read through that list of files gets to that file that disappeared, it'll say, this file, I can't find it. And that particular I can't find the file error will get sent to standard error. So if you're outputting standard output, normal, I'm searching for this thing in this list of files, when you get to, if you're piping that standard output into another application, and then that error pops up, that error will go to your terminal because your terminal is both standard in, standard out, and standard error typically all the time unless you redirect one of them. So that I can't find the file will just show up because you didn't capture it. So oftentimes you'll say to out dev null never land. So if you include that in your pipeline, you say command 1 send errors to never land, pipe command 2. You can take this stream, send it to Never Never Land, and send your standard stream to the next command. Alright, so other ways of combining commands, there's both conditional and non-conditional ways of combining commands. So if you have command 1, semicolon, the bane of C programmers everywhere, command 2, this is non-conditional. So as soon as command 1 completes, whether it succeeded, failed, ate your kernel, doesn't matter. As soon as it finishes, the next one will run. But if you need one to run only if the previous one succeeds, you can say command 1 and command 2. This is continue on success. And if you want to continue, and if something failed, so perhaps you're testing if a file doesn't exist, you want to make sure that something isn't there or doesn't exist or doesn't meet some criteria, you can say command 2 or pipe or command 1, 2, I can count. Alright, so we have command 1, pipe, command 2, continue on failure. Now, when I mean success and failure, what I'm referring to is the exit code. So every utility you run, every command that you run has an exit code. Typically the exit code is either 0 or 1. 0 means everything happened the way I expect it to happen, or at least I didn't run into any errors. Exit code of 1 through 255 is something went wrong. Either it had an error, or it couldn't find a file, or it couldn't read something, or whatever it might be. If you get a non-zero exit code, it means that something didn't go right. And the application says, I had an error, or the test failed, or whatever along those lines. I've used this before. If you're, say, rsyncing a directory from point A to point B, and then you need to remove the original directory, and then you need to rename the new location back to the old location, you'd say rsync and remove this and rename the thing, and then presumably if your rsync has an error somewhere along the line, it won't toast your source. It would be bad if you use a semicolon and then your rsync failed, and then, oh no, I RMRF'd that directory and it's gone now. My source is gone. Well, it copied some of it. So this can be useful in that sort of situation where you've got this command needs to complete, and it needs to complete successfully, or at least successfully as far as the shell is concerned, and then run the next command. Actually you can reference the exit code by calling a special sort of like shell variable. The shell variable is $? And this equals the exit code. Exit code of the previous command. So you can actually like reference this as an if statement if you wanted to, which we'll get to. Alright, so we've got ways to combine commands, conditionally and unconditionally. Everybody reasonably cool with that one? Alrighty. Alright, so everything in the shell or everything in bash is text unless you tell it to not be text. Now, one of the ways that you can tell something that it's not text is to reference like a variable name. So you do a substitution. You say, var equals hello. Whoops. Hello. Var 2 equals world. So we have these variable names. We set the value of the variable name using equal signs, and then we can recall that. So we can say, you know, echo var, we'll call that 1, just so I don't get lost. All right, so var1, var2, hello world, echo var1 will produce hello. And if we say echo var1, var2, we get hello world. If you use a character, if you wanted to insert something in here that the shell might interpret as a part of the variable name, you can capture the variable name by using squiggles. So if we want to say echo var1 underscore var2, if we don't capture this name, the shell will think that our variable name is var1 underscore, because underscore can be part of a variable name. Periods and dashes, I think, aren't valid variable names, and so it will automatically understand that that's just a character, just a piece of text in between your other variables that are going to be expanded or substituted. But in this case, because the underscore will get interpreted as part of the name, we can put a curly brace, but I like to call it squiggle because that's what it is. It's a squiggle. So $squiggle var1 squiggle underscore $var2 will present us with hello underscore world successfully. There's a whole lot of other stuff that you can do when you capture something in squiggles. There's a whole chapter in the Bash Programmer's Guide about Bash expansion and those crazy things you can do inside the squiggles. But for most people, most of the time, you're just capturing a variable. You're very explicitly defining that reference to that variable name. If you need to do math in Bash, you have to tell it that you're doing math. You can do that though. So if you do double parentheses, and then you say, we'll come over here, we'll say var 3, var 4, 10, 2, we'll say var 3 plus var 4. Now, this will execute, and this statement will have a new value. In order to reference this, you need to treat it as an executable statement. So you'd say like echo, and the $paren says, execute this math. So this will result in 10 plus 2 is 12. You can also do multiplication, division. I believe you can do a modulus statement here to get the remainder of something. But and if you just needed to, if you needed to say, if you wanted to set something equal to this, you could do that too. You could say, you know, result equals this statement. There's also a calculator built into the shell called BC. It's actually a Bash built-in. You can do all sorts of floating point math in here. This is all integer math. This will not give you decimal places. It will round it off to the next whole number. And so if you need decimal places or square roots or things like that, you need to utilize BC. But BC is beyond the scope of this talk. So we'll keep on keeping on. But we kind of mentioned here the use of an executable statement, or like a sub-shell command. So you may have seen this before, you can use this like backtick or like grave character. This is perfectly valid, but if you need to nest these, it becomes really pain in the butt. So it's better to, I think it's better to do this. So you can say some variable equals the output of this command, or if you've got perhaps like a for loop or a while loop and you're generating a list of files, you can run the command that generates that list of files, and then this will execute and then be substituted. You're substituting the output of this command into some larger command outside of it. So we've got variable substitution, we've got command substitution, we've got special math substitution. Any questions about that? Pretty good? Blowing your minds? Magic. All right. Either that or this is all hold a hat and you're all bored. One or the other. Hopefully not.
That's good stuff.
All right. So the next concept to cover is globbing. So anytime you use like star, or you say star dot mp3, you've got some list of audio files and you want to capture that list of files. You've all probably used this before, but this is referred to as globbing. The shell takes this special character and says, I'm going to match everything that, I'm going to return everything that matches this sequence. You can actually also use some amount of regular expressions in globbing, and there's a shell option that you can set to do fancier globbing. It's like shopt-s extend or ext glob. Also sort of beyond the scope of this talk. But basically you can also do like 09 star dot text. This would return every text file that begins with a number as part of the file name. You could also do, star az dot log. Every log where the last letter is a letter, capital letter in this case, because I wrote in all caps. But this is good when you're building a file list for like a for loop. You don't want to ls. You don't want to do this. Because you don't necessarily know what file names are going to match this. And if one of those file names has a special character in it, or like a space, particularly spaces or white space, then the shell, because its file separator, its IFS, I don't even know what IFS stands for, I just know it's a file, like the standard separators are tab and space and things, and new line, basically your white space characters. So if your file name is file with spaces .mp3, because we're matching this. So file with spaces .mp3, if you put that, if you get that as a result here, the shell says I have one item, I have two items, I have three items. And what you'll end up with, if you say for x in this, do something, you're going to end up with file name file doesn't exist, with file name with doesn't exist, file name spaces doesn't exist. But if you do this, particularly if you do, current directory star.mp3. So if you do this instead of this, the shell will understand that this whole thing is one file because it's doing the matching, it's doing this, and it will capture like the escape sequences that are necessary in order to get the correct name. And you'll get expected behavior instead of potentially unexpected behavior. One of the very first things that I learned in talking to somebody about shell scripting, I said, yeah, I wrote this for loop, and I did ls, this thing, and I for looped over, and he looked at me and he said, don't ever do that again. That's terrible. That's terrible. Don't ever do that again. I was like, but why? And he told me, this here, unexpected behavior. I also asked that person, I said, how can I learn all of the things that you know about everything? And he said, well, so step one is to work third shift alone with no one to call to help you and read all of the man pages for everything in /bin. And I was like, cool, not going to do that. That sounds painful. All right, so we've got globbing, we've got command substitution, which leads us into loops. So sort of the big workhorse in the shell is loops. That and if statements, but we'll get there. That's sort of the conclusion to the talk. So you got for loops and you got while loops. For loop is going to loop over some predefined list. You can define that numerically. You can run some command that finds a bunch of file names or does some sort of matching or searching to generate a list of files or generate a list of whatever you're looking for. But you've got a predefined list, and it's going to read through that until it gets to the end of the list. So we've got for some var, typically x or I or whatever floats your boat. If you are writing something that's going to be run by other people, it is helpful to have descriptive variable names. But for purposes here, we'll just use var, or I'll probably switch to x at some point. For var in, and here we're just defining the variable name. We're not actually referencing it. So here it does not have the $sign at the beginning of it. The reference of it inside the loop will have the $sign. So we've got var here, for var in list, and I'm just going to say generic list, however you want to generate that list with subcommand or glob or whatever. Semicolon, do stuff. Potentially to var. And then done. So this, you generate a list in whatever way you generate a list, and then you're going to loop over that list. Basically, its end condition is I have no more input. I have no more list to go over. A while loop can function in the same way, parsing over a list, and then it will exit when it reaches sort of end of file or end of input. But a while loop can also do its own conditional. Like you basically have an if statement inside of your loop that's checking to make sure you have some condition met. So you say while this is a square bracket. I will pretend to write nicer. Condition do stuff done. And oftentimes you use a while loop in this way to read over a file. So you'll say while read var do stuff, and you can reference that var done, and then we use that input from earlier, input file. So we're reading this file, and we're actually our implied if statement here is that the read command exited successfully. As soon as the read command does not return true, does not return I successfully read a line of input, oftentimes you'll say while read line, because line is a descriptive variable in that case, you say while read line, because I want to pull one line from the file at a time and do something with it. While read line do stuff to the line, you might echo that line into awk and pull some particular piece out of it. And then you finish, but our test in here is, have we reached the end of file? Have we reached the end of input? By the same token, you could have some other command over here, and you pipe that in. And again, we're basically waiting for read to say, I have no more input, I have failed to read input. So, and now if you are just looking for iterations, you need to initialize your while loop. So if you say, so we'll expand on this. So we'll say while I, let's say x less than 10. And here, because I'm doing a numerical comparison, which comes back to that, if you're doing math in the shell, you have to very explicitly say, I am doing math. So here, this is a numerical comparison. We'll get to all of the other different comparisons you can do inside of a conditional statement. But if I'm going to loop through here, and then somewhere in here I'm going to add 1 to x until I get to 10, we have to actually say, x equals some initial value. We'll say x equals 0. We initialize to 0 while x is less than 10. We do something. We add something to our variable. Eventually it becomes greater than 10, and it drops out of the loop because we've gone beyond our condition. Everybody cool? All right. No eyes glazed over. All good. All right. I feel like I'm going really fast.
If we need to, you could jump on the screen and do some examples in the terminal if you want to.
All right.
Might not be able to record, but that's fine.
All right. All right. So we've touched on conditional statements in that while loop, and so I use that double square brackets as I am testing something. So that brings us to conditional statements, basically meaning if statements. So our general form is if condition, then not 10, then action B. So in a lot of programming languages, you'll have if and then end if. In the shell, phi is your end if statement. So you always have to have if and your end if. You can also do if condition, then action, else, other action, phi. Now, this is a catch-all. If our first condition is matched, positive, negative, whatever, if our first condition is matched, then we do the first thing. In every other case, as long as this doesn't work, we go and do the other thing. Sometimes you want that, sometimes you don't want that. If you have multiple conditions that you want to meet and you don't want to have your catch-all, you can do that. You say if condition, then action, elif, condition 2, then action 2. Now, I can end this here and say phi. I have no catch-all. You can also add an else in here. You can also have as many elifs as you need. So you can say elif condition 2, oops, 3. Again, I can count, I promise. Then action 3, B, like that. Now, if you get a ton of these, and they're all relatively simple pattern matches, then you might want to explore something called a case statement. Beyond the scope of this, but I'll just touch on it so you know it exists. You can Google just as much as anybody else. All right, so I keep putting in here this condition, but what are the conditions that we can actually use here? Everybody pretty much cool with this format? All right, I'll erase everything except the top one so we have it for reference. All right, so what can we put in a conditional statement? Now, again, like I said before, on the backticks versus $paren, it's just a personal preference, but I think there's some value to it. I read what I thought was a good article. It's called the Bash Pitfalls Wiki on, it's like woolidge.org. Google Bash Pitfalls Wiki, you'll find it. It's like 50 or 100 things that are just like bad form that can result in unexpected behavior. It's a good place to start. It's one of the places I started in learning about all the shell stuff. In that discussion or in that article, they basically say to always use the double square brackets. You can use single square brackets. You can use a command called test. There's multiple ways that you can test a conditional statement, but this is the one that's sort of most flexible and most reliable. So that's my personal preference to use that, and that's why I just I will be using that consistently here. So in our condition, we can do like file tests. We can say is a directory. We can say is a file. Exists. Is executable. I use this if I want to run something like the pipe viewer command that isn't necessarily installed everywhere. I'll say, is PV executable? Oh, no? Okay, well, it's probably not installed. Let's install that. We can also do, let's see, we've got -s is file of non-zero length or non-zero size. So you can check, does this file exist and is it not empty? That is often handy. And then we've got some string tests, N and Z, string of non-zero, there's a pattern here, length, and string of 0 length. So here we're checking, does our string, the result of some command, some variable that we've generated, is it a non-zero length? Does it have a value? Does it exist? Versus, does this string or this output or this variable have a 0 length and basically represent empty? Now there's some other string comparisons. You've got equals, string 1 equals string 2. This could be a variable, whatever. You're comparing those. You've also got not equals. And you can also, this is not equal, not equal. Here you can also do a bang in front of that to say is not a directory, is not executable. Humorously, you can say is not non-zero length, which is equivalent to Z. I've seen people do that. Why would you do that? The particular person in question said that it was, to them, it was a more clear definition of what they were trying to do. They're checking, does this exist? Does this not exist? I'm like, okay, whatever, touche. All right. Oh, and as far as these go, so we've got, there is actually a regex match that you can do inside of an if statement. You can say equals tilde. Does string exist within some regular expression? So you can actually do a regex pattern match as a string comparison inside of an if statement. Or you could do that similarly inside of the while loop that also uses a conditional statement. So these are like file tests. These are string comparisons. And then there's actually a subset of math tests or arithmetic comparisons. Everybody cool on this so far? Alrighty. Again, I feel like I'm going really fast. Normally this talk takes like 2 hours. I was going to make a joke about keeping it to a tight 75, but I think I'm doing really good on time. Alright, so our math tests are, so if you were, so we've got our equals, our not equals, our equals regular expression. These are actually string tests. These are, I can't remember exactly how the man page describes it, but it is a, like, logistical, or like, I don't remember exactly. Lexicographic, that's the word they use, lexicographic. So this is actually, does string 1 sort before or after string 2? And again, coming back to the, if you're doing math, you have to tell the shell you're doing math. If you say, is 22, for example, we'll say, is 22 less than, what do we want, 215. It's not. It's actually bigger, because this 2 is bigger than that 1, alphabetically. So I sorts before B because A comes before B. So don't get held up with, this is actually a string comparison. It is an alphabetical sort comparison. All right. Which will work sometimes, but will also not work in other times. All right. So if you want to actually do a mathematical comparison, you've got less than, greater than, equals, greater than or equal to, less than or equal to, and not equal. So this mathematically less or equal, not equal, greater, or equal, distracting myself, greater than and less than. And when you use these, whatever string that you're comparing to some other string, the shell will understand to try and interpret those as numbers. Now, if it's not a number, you will get an error. You can't say, 10 less than apple, it will say I cannot make this comparison because this cannot be interpreted as a number. All right, and that. Oh, we have one last sort of bonus here. If you're troubleshooting a shell script and you're like, man, it's doing something funny, something is not getting set, some variable is not getting a value and I don't know why, you can actually tell the shell to give you debugging output. You do generally have to take whatever you're writing and put it into a script form. If you've got a big long one-liner that wraps 3 times, just copy paste it into a script, save it to a file, put the magic number at the beginning, and the magic number being the hash bang bin bash. So this is the interpreter line inside of a script. It always has to be the first line, and you can't have anything else on that line, including other comments. So you put this at the beginning of your script, you drop your one-liner in, doesn't matter, the shell will interpret it. Spaces, no spaces, white space, be damned. You can just squinch it all in there, minimized, and the shell will still run it. What you can do is you can say bash dash x script name. And what this does is it tells the shell, or your interpreter, it says, give me debugging output. And it will step you through that entire script. And it'll tell you internally, this variable was set here. This test succeeded or failed. I mean, it's not exactly that verbose. It's not that doesn't speak English. But it, you can see this conditional statement was run. This evaluated to, it does all of the variable substitution. It does all of the command substitution. It does all of that expansion to get you to, here is what I am interpreting. And I've run into stuff where, oh, my grep failed because this regex didn't match, and so this variable didn't get set. Oh, okay, here's where that ended up with a null value, or it ended up with an empty string. And so this is really, really useful when you're pulling your hair out going like, what is going on? Anyways, so that is the end of my content. Normally I intersperse with examples and funny anecdotes, but can't get the TV to work, so you got the chalkboard.
Right,
what?
You should be able to right now.
I mean, if I knew the password to my wife's laptop, because mine didn't talk to the TV before. Totally got chalk on your keyboard now.
Yeah, you're in trouble.
It's forever tainted.
It's not right, because
Nope.
everyone's looking at me.
Mm-hmm.
You can turn the sodium to.
Alright, alright. So an example. So we'll say while, alright, click the thing. While, where's your home button? There's no home
It's
button.
a function of the
Oh,
arrow keys.
good lord.
Super dumb.
Oh, good. See, I said your keyboard nib was inferior. This keyboard is inferior. All right, so we're going to initialize a variable. We're going to say I equals 0 while all right, so while our variable I is less than or equal to 10, actually let's say 5 so we can fit it on the screen. Do echo I almost there, and then we will do our math and we will say I equals, or actually we'll say I plus plus To increment it, we'll say done to finish our loop, and we'll say echo made it. And oh, I totally now remember what I skipped over, so I will have to go back to that.
If you zoom in a little bit,
All right, so
zoom in a bit more.
zoom in more.
It's a Control-Shift+.
Yeah. Well, I figured that was big enough, but we can make it bigger. All right. So in our while loop, we start off with an initial value of 0. We increment it with our plus there, telling it to do math inside of the double parentheses. We're testing if our variable is less than or equal to 5. And here we go. 0, 1, 2, 3, 4, 5. Made it. Got to the end. Yay! Great success. But if I take this, copy. All right. Yep. Please tell me that Nano is installed.
Maybe?
Okay.
You're on your own.
You mean them, right?
Sure. Yeah. I'm a nanotard. I don't care. Bin.
Whatever works. I don't know. Listen, you with your text.
Yeah.
All right.
I don't think it's ever been run on that machine.
Probably not. Although you clearly have the include files because it's giving me color codes. So, you know, cool beans on that.
Default.
Yep. All right. So, so if I do /test, it's not going to do anything because the file's not actually marked as executable. It says I can't actually do that. I can .test. And this doesn't actually like run it, it sources it, which is different. But it will run it without being marked executable, which is kind of neat.
Yeah, it is.
So let's chmod plus x, our thingy test. But okay, what we can do here, and I'm probably gonna have to scroll. Okay, bash -x, and we can see, okay, here's what our variable was set to. This is the conditional statement that was run. This succeeded, then this command was run as a result using the substituted value, and then this is the output. So we get we get all the internal commands as well as the output. And then eventually here we get to 6 is not less than or equal to 5, and we drop out of the script, out of the loop. If we do, you know, for x in, and this gets into some of that like expansion that you can do inside the curly braces. We'll say 1.5 do echo x done. We get that. You could also do, you know, 10.2. So here, this expands into the list 1 space 2 space 3 space 4 space 5, and then the for loop iterates over that white space delimited list. In here, we were actually setting the start, the stop, and the step. So it goes 1, 3, 5, 7, 9. And if I change that 10 to an 11, it'll actually do the last number. But, you know, you've got some command, you need to run it 1,000 times. You need to run it 1,000 times only if something is met, or only if some other thing is met. You can use the loops and the if statements, the conditions. You can tell your script to make a decision based on some condition in the environment, in the output of a command. You can basically tell the shell, do all of this for me. So hopefully that encourages you to tell the shell to do more of your work for you. All right, any questions, comments, concerns, nitpicks, attempts to start fights? Candy, I like candy.
Seriously, Nano?
Yeah, yeah.
Come on.
Can we talk about Nano?
We can totally talk about Nano, and I will not care.
I've tried to teach him Vim like 4 times, and he's like,
Nope, not gonna do it. I've even tried to use Vim Tutor, and I'm just like, nope, nope, nope. I want my text editor to be in edit mode. Because edit mode.
It's
Say,
such a weird request. My text editor in edit mode.
I know. I mean, you know, Emacs is like a whole operating system that would only be feature complete if it had a good text editor. In the Church of Emacs, they do not speak of the other, but they do speak of the mark of the beast. VI, VI, VI. I know. That's about all I got, though. Giving you all my A material. I'm just like out. I'm spent.
You know they say, end of a strong one.
All right. Anybody else? Other than my wife being
Oh.
snarky?
I don't think it was snarky. It was just
but I was
clarification.
saying I was snarky.
Ah.
Not yet, you're fine.
Just clarifying earlier, and we sorted it out. Was you kept talking about star, and like, it means wild card, right?
Yes. Yes.
Yeah,
Yes.
Yeah.
it's fine. It was just terminology.
Okay. Fair enough.
They're terrible to write.
Well, I mean, I use star, in waka, out waka, and squiggle. So as long as you followed.
Yep.
Yeah, we're good.
Good job. All right.
Cool
Thanks.
beans. So this is like a brief overview of programming in general, just in the context of the shell.
Your previous audience